Imagine standing on a beach at sunrise. The horizon glows orange, waves roll in, and overhead, the sky curves not as a simple dome but into a vast, hollow circle. Far across the heavens you glimpse a ribbon of daylight from the other side of the world, a shining band suspended in space. You live on a planet shaped like a torus, a colossal cosmic donut. What would life be like if Earth really had a hole through its center? Let's spin the fantasy into reality and explore the gravity, weather, and culture of a world where our home is a ring of rock and ocean. Start with the basics. Our current Earth is a nearly perfect sphere, its shape the natural outcome of gravity pulling equally toward the center. To form a torus you'd need an extraordinary event, a ring of debris collapsing around a void and somehow stabilizing. Perhaps early in the solar system's history a colossal collision or exotic physics left behind a dense ring that never filled in. For a donut Earth to remain stable it would need to be much larger in diameter than present-day Earth. Picture a thick ring with an outer diameter similar to our current planet but a hole wide enough to keep the inner rim from collapsing. Gravity would be the key difference. On a spherical Earth, gravity pulls toward the center of the planet from every direction. On a torus, gravity would draw objects toward the thick band of mass surrounding the hole. On the outer rim, the side we'd think of as normal ground, you'd feel something close to Earth's current gravity, though it would vary depending on how far you are from the ring's center. Closer to the inner edge, the gravity vectors tilt outward toward the thick ring. You'd feel a sideways pull, as if standing on a mountain slope. Travel far enough toward the central void and, down, would point toward the inner rim, not the geometric center. Inside the hole, floating in the open air of the void, you'd experience almost no gravity at all. The mass of the ring pulls equally in all directions, canceling itself. The very center would be a natural low-gravity arena, a permanent, planet-sized space station. These differences would shape everything: how oceans settle, how air circulates, and how people move across the surface. Water would pool along the outer and inner surfaces of the torus, but the oceans would not be neat belts. The outward sloping gravity would drive currents from outer to inner edges. Great circular seas might ring both rims, while the central void could be shrouded in a perpetual mist as air and water vapor circulate through the hole. The atmosphere would wrap around the ring but thin dramatically near the center. Air would tend to flow toward the massive band, creating persistent winds rushing through the void. Think of a planet-scale jet stream. Sunlight passing through the gap would paint the sky with brilliant halos at dawn and dusk. Our familiar 24-hour rhythm would change dramatically. As the planet rotated, the inner rim would see the sun rise and set multiple times each day, because sunlight could pass through the central hole and back again. People living on the inner edge might witness 2 or even 3 distinct sunrises in one rotation, with dazzling reflections from the opposite side of the ring. The outer rim would have more conventional days and nights, but the long curvature of the land would stretch twilight into spectacular, lingering glows. Cities built along the inner rim might thrive on near-continuous daylight, while outer settlements would enjoy longer nights perfect for astronomy. A donut Earth would create bizarre climate zones. Warm air rising through the central void would draw cooler air from the outer edges, powering immense, never-ending cyclones around the inner rim. The low-gravity center could accumulate a permanent cloud torus, an endless silver storm visible from every point on the ring. Ocean currents would circulate around the torus like giant conveyor belts. Regions on the inner edge might be humid and storm-lashed, while the outer rim could host vast deserts or frozen plains depending on distance from the sun. Life would adapt to these gradients. Plants near the inner rim might evolve to cling sideways to the tilted gravity, growing along the slant like ivy on a wall. Animals could develop powerful limbs or specialized senses to navigate the constant crosswinds. Migratory species might travel the entire ring, chasing the shifting bands of sunlight. Human architecture would take advantage of the geometry. Cities could hang like balconies on the inner rim, their windows opening onto the star-filled void. Transportation might include elevators or gravity trains that climb the angled pull from outer to inner edge. The near-zero gravity center would become humanity's natural launchpad for space exploration, a region where ships could depart with minimal fuel. From space, Donut Earth would look spectacular, a glowing ring lit by city lights, with the sun often visible through the gap. But orbits around it would be tricky. The gravitational field of a torus isn't symmetric like a sphere's, so satellites couldn't follow the simple ellipses we use today. Spacecraft would need complex paths to stay stable, weaving around shifting gravitational lobes. The Moon, if it formed at all, might orbit the ring's center rather than the torus itself, producing multiple eclipses each month. Tides on the surface would be wild and irregular, reshaping coastlines in endless cycles. Think of the stories people would tell. Ancient astronomers would gaze through the central void and watch stars appear where Earth should be, perhaps believing the hole was a gateway to the heavens. Religions might place their gods in the glowing mist at the center, while explorers would dream of floating cities suspended in the low-gravity void. Navigation would also change. Instead of north and south, people might speak of outer ward and inner ward. Maps would be circular, trade routes spiral, and the concept of a straight line would mean something different on a world wrapped around a hole. Could it really exist? Physics makes a real torus planet unlikely. Gravity naturally pulls matter into a sphere. A ring would collapse without some stabilizing force, perhaps rapid rotation or exotic matter we've never observed. Even if such a world formed, it might be unstable over cosmic time, slowly thickening until the hole filled in. But imagining it teaches us something profound. The shape of our planet dictates everything from weather to culture. Change that shape, and you rewrite the rules of life. So if Earth were a giant cosmic donut, our sky would blaze with double sunrises, our seas would race along tilted shores, and the very idea of up and down would depend on where you stood on the endless ring. It's a reminder that the universe allows stranger possibilities than we usually picture, and that even the simple comfort of a round horizon is part of the delicate design that makes our world home.